Hi everyone. The topic of our presentation is working effectively with legacy system. This is Anchal and I'll be talking about legacy systems and the problems faced while working with them. Legacy system can be a software, programming language, application or a technology which is now old and is no longer used. Age is not the only factor on the basis of which a system might be termed as legacy. It might so happen that the system stops receiving vendor support or they no longer meet organizational standards. They still exist and are maintained, reason for which will be covered later in slides, mainly because they are responsible for core business transactions and capabilities that represent the livelihood of the organization. These systems have led the way for upcoming standards and hence are aptly named as legacy. Now coming to the common problems faced while working with legacy systems. Huge change in operational environment and high system maintenance cost. For example, if the legacy system software runs only on antiquated hardware, then the cost of maintaining the system may eventually outweigh the cost of replacing both the software and the hardware, because antiquated hardware is generally more expensive. Maintenance and staffing costs are high and growing. It's not just overtime costs that drive up the expense of maintaining legacy systems. These systems are generally hard to maintain, improve, and expand because there is a lack of understanding of the system. Because the staff who were experts on it have retired or have forgotten what they knew about it, and the staff who has entered the field after it became legacy never really learned it in the first place. This situation is further aggravated because of lack of proper documentation. Then, these systems have limited functionality and prohibit innovation and growth. As we all know, today's world demand instant and easy access to as much information as possible. In order to effectively compete, businesses require accurate information in real time and immediately availability from multiple sources. Legacy systems simply cannot meet such high expectations. These systems suffer from possible security vulnerabilities due to lack of system patches available at the time, putting legacy systems at great risks of being compromised. Integration with newer systems may also be difficult because new software may use completely different technologies. Further, performing migration may also be a problem because most legacy programmers are entering retirement age and the number of young engineers replacing them is considerably very small. Last but not the least, legacy systems were built with data-driven programming languages and is often difficult to extract business content from them. For example, process bottlenecks are nearly impossible to identify, workloads can't easily be balanced or manipulated, and legacy systems provide limited ability to see business trends. As numerous problems are associated with legacy systems, we have two options, either to replace the legacy code or to keep maintaining it.
Now, we know the problems associated with legacy systems. So, if the company we work for is using legacy, they have two options. Either they can replace the system entirely with modern technology systems, a topic we see on this slide, or they can continue using the current system and simply modernize it to fit changing business requirements. The legacy systems use old technology. For example, some are based on DOS, COBOL, etc. As these technologies have become obsolete, it is difficult and expensive to maintain them. This is because proper support is not available. So, if your system needs to comply to a lot of government regulations, for example tax laws, then you might need to invest in updating the processes to fit compliance. If such scenarios happen often, it might be time to replace the system. However, it doesn't make sense to replace in every situation. You might have heavily customized your system. For example, you might have updated an existing payroll process that used COBOL and SQR and customized the output file to show only specific columns. You would lose this customization and would need to invest in it again if you move to a newer system. Often, such changes are undocumented and they might be lost forever. As you can see on the slide, it might be cheaper and better to modernize your legacy through vendor support or third party. Replacing the system entirely would involve a lot of time and money investment. It might easily take more than a year to replace the system, and that system might have errors. You would need to keep using the older system until the new system is completely set up. We also cannot downplay the importance of customer and employee familiarity with the existing software. So, it depends on the situation entirely. Just because the system is legacy doesn't mean it needs to be replaced. There can be many benefits of maintaining a legacy system. You just need to make sure that the system is maintained and modernized properly.
We can follow a simple algorithm to work with legacy code. As seen in the flowchart, the first step is to identify the change points. The point of change in the code may be residing deep inside other methods, or in a long if-then-else loop, or it must be buried in classes referenced by other classes, which must be further referenced by newer methods. We need to find this point of change. To make the code better, you should know your design well enough to make the changes in the first place. When reading through the code, it may get confusing at times. We should start drawing pictures and making notes. Sketching dependencies while reading the code would give a good overall review and outline of the code. The second step is to find the test points. Find out where to write your test, and it is important to know what can be affected by the changes we make. What methods should you test? The new ones as well as the old ones affected by the change. The third point is to break dependencies. So the basic idea here is that the code is built upon methods and interfaces. Many times the new methods and parameters that we initialize may conflict with the already existing ones. In such cases, we need to build a new interface or a dummy parameter known as the adapt parameter to break the dependencies. The fourth step is to write the test. The tests written in legacy codes are very different from the tests written for new codes. The test should incorporate all scenarios from the best case to the worst case and aim to achieve the optimum output. The last case is to modify and refactor the code. Feature-driven development is used in this phase where the test is written, and if it fails, then it is refactored and it is made to compile. This is done until the test cases are resolved. This was the algorithm to work with the legacy code. We'll now further see examples of how to implement this.
Well, that was one striking algorithm. Hi, my name is Mahima, and I'll try to elaborate on this algorithm by taking an example. Well, everyone has heard what Instagram is, right? If you would have noticed, Instagram rebranded itself a few years ago into that beautiful pink logo in the right. Let's assume while the visual effects were successful, the behind the scenes elements didn't work out so well for Instagram. What do you think would have happened? I guess you might have predicted. Instagram has a million users who log into it every day. How do you think it would have affected the brand if Instagram was crashing every 2 minutes? Definitely, the team would have to come up with something quick and fast to save Instagram from all the embarrassment. Well, that's where legacy code based solution comes into picture. It's something related to change algorithm, and I would like to take you through the steps of it. The first step is to find someone who knows the design of the product really well and can find the production bugs quickly. The second is the most imminent step where you have to see which bug should be fixed first. Like you have to prioritize your bugs. The ones facing the users have to be corrected first, then the ones which are not really visible. The third step would be stabilizing the code and finding all dependencies before making the tests. You wouldn't want the test not to work or the product to fail even more, right? So this is a necessary step. The fourth step would be fixing the test by fixing tests of specific bugs and then um, creating other tests for other bugs and so on and so forth. The fifth would be like implementing the tests, doing the refactoring, and obviously cutting all your costs. Yeah, I guess that's about it.
Legacy systems are usually related to outdated codes and technologies, but it's not always the case. Let's consider a scenario of a startup company. The team has already finished all the coding using the latest technology. But they soon realize that the code quality is poor. Whenever they try to add a new feature, they break three other things in the code. But they have a demo in 3 weeks. So they have to decide what to do with this code. Should they rewrite the code or edit the code? But there's no time to rewrite the whole code from the scratch, hence they decide on editing the code. While editing the code, they use algorithm which is explained previously in this presentation. Firstly, they identify the change points. The main aim of the company is to impress the customers with the demo. Someone that sees a demo isn't going to look under the hood. Instead, they're going to make a decision to buy or invest in the product based on what they see in the demo. Hence, the main focus will be customer facing features, which are change points. We usually need to create test points to check if their new features are implemented properly without disturbing the other features. But as the goal is to get a feedback from the potential customers or investors, intentional technical depth is used. Here we neglect the less important features and focus on our priorities. So in this scenario, we focus on the user features and only write the tests which will help finish the features faster before the demo. Once the demo is done, the code can be improved gradually by making changes and refactoring it.
Hi, this is Aditya. So, the presentation discussed what legacy systems are and the problems associated with it. We can all agree that handling legacy code can get difficult. The technology used might be obsolete, maintenance of the code might require a lot of investment, and there are obviously security issues, and so on. One option might be to replace the legacy system with a newer technology. But as we saw, it comes with its own set of cons and risks associated with it. Sometimes there is no way around it, as there might not be any room for mistake. The system might be a safety critical one, which needs to be operational at all times. Legacy code should always be handled with care. A good starting point is the algorithm which we have mentioned in the previous slides, which is quite a generic one and can be applied to most of the scenarios. An eye should always be kept out on who is contributing to the code, as it's always beneficial to reduce the as many as errors possible in the earlier stages rather than finding it out during the testing stages and fixing it at that time. And this specifically is more important for the legacy code. One of the most important aspects of maintaining the legacy code is that whenever a change is made to the legacy code, a thorough testing has to be carried out with almost 100% test coverage. In fact, legacy systems become attractive to use if the organization has capabilities for verification, validation, testing, and operational history. Because then we have the trust on the product even after a change has been made, that a proper testing can be carried out, and if there is any mistake or any error, that can be rectified later. And yes, you can maintain the legacy code. Legacy code does exist, and in a big way in the current scenario. Rather than it being something to be afraid of, it should be embraced. NASA, in one of its retired shuttle program, used a large amount of 1970 era technology, as the amount of time taken to migrate to a new technology and certify it would have rendered the new components itself obsolete. And maintenance of legacy code just requires a lot of extra care, patience, and lots of testing on making any change. Hope you have a good time with legacy code.